Lightning is one of the most dramatic natural events we experience on Earth. We see it during thunderstorms as a sudden flash of light, followed by a loud crash of thunder. But what exactly happens when lightning strikes? And why is it so hot? One of the most amazing facts about lightning is how incredibly hot it gets. The temperature of a lightning bolt can reach about 30,000 degrees Celsius. To put that into perspective, the sun's surface is only around 6,000 degrees Celsius. That means lightning is roughly 5 times hotter than the surface of the sun. Before we dive into the heat of lightning, it's important to understand how it forms. Lightning is essentially a giant spark of electricity. In thunderstorms, the air inside the clouds gets charged with electricity. This happens because of the movement of ice particles and water droplets inside the storm. These particles collide with each other, causing them to become electrically charged. The top of the cloud usually gets a positive charge, while the bottom gets a negative charge. This creates a huge difference in electric charge between the cloud and the ground. When the difference becomes large enough, the electric field is strong enough to cause a spark. This is lightning. The spark can travel between different parts of the cloud, between the cloud and the air, or between the cloud and the ground. Now, let's focus on the heat of lightning. When lightning strikes, the electricity travels through the air, which normally doesn't conduct electricity well. The sudden flow of electricity through the air causes the air particles to heat up instantly. The temperature of the air around the lightning bolt can soar to about 30,000 degrees Celsius. This is incredibly hot. Why is it so hot? The energy released in a lightning strike is enormous. A typical lightning bolt carries about 30,000 amperes of current and can last for a fraction of a second. This burst of energy is enough to raise the temperature of the air in the path of the bolt to extremely high levels. The air molecules, mostly oxygen and nitrogen, get excited by the electric current, causing them to vibrate and collide with each other. These collisions generate heat, which causes the surrounding air to heat up rapidly. Since the bolt is so powerful and quick, the heat doesn't have time to dissipate, which is why it gets so hot. To help visualize just how hot lightning is, let's compare it to something we all know about: the sun. The sun's surface temperature is about 6,000 degrees Celsius. This is the temperature of the visible outer layer that we can see shining in the sky. But lightning at 30,000 degrees Celsius is 5 times hotter than the sun's surface. It might seem surprising that something on Earth can be hotter than the sun's surface. After all, the sun is enormous and incredibly powerful. But here's the key difference. The sun's heat is spread out over a massive area, while lightning is a quick, concentrated burst of energy in a very small space. The intense heat from the lightning strike is focused in one small place, which is why it can reach such extreme temperatures. The extreme heat of lightning causes a number of interesting things to happen when it strikes. For one, it can cause the air to expand rapidly, which is why we hear thunder after a lightning bolt. The air around the lightning bolt heats up so quickly that it causes a shock wave, which travels through the air and creates the sound we recognize as thunder. The rapid expansion and contraction of air also create the loud bang or rumble of thunder. Lightning can also have a powerful effect on objects it strikes. For example, it can start fires by igniting dry materials like trees, grass, or buildings. The heat is so intense that it can melt metal or vaporize materials instantly. In some cases, the force of the lightning can even cause buildings or trees to explode or break apart. With such intense heat, it might seem like lightning would cause a lot of harm to everything it strikes. But, in reality, the heat of the lightning is very localized, and the lightning bolt only lasts for a very short time, usually less than a second. So, while the area directly in the path of the lightning can get extremely hot, the heat doesn't spread out over a large area. Also, the air itself is not a good conductor of heat. While the lightning heats the air around it to thousands of degrees, the heat quickly dissipates. This means that while someone standing near a lightning strike may feel a shock or experience burns if struck directly, they won't be affected by the full heat of the lightning in the way they would be if they were in direct contact with the bolt. In summary, lightning is an incredible natural phenomenon that can reach temperatures of around 30,000 degrees Celsius, which is 5 times hotter than the sun's surface. This intense heat comes from the electricity flowing through the air during a lightning strike, causing the air to heat up rapidly. Even though lightning is much hotter than the sun's surface, it is only concentrated in a small, short-lived burst. Understanding the science behind lightning helps us appreciate the power and mystery of these electrical storms, while also reminding us of the importance of staying safe during a thunderstorm.